Page 27, Module 1.5, Elasticity of Demand. Rationale. Elasticity of demand shows the responsiveness of the change in the quantity demanded of a good due to change in the price of all other factors remaining unchanged. Key concepts: elasticity of demand, inelasticity of demand, perfect elasticity, perfect inelasticity, unitary elasticity, linear demand curve.
1.5.1 Price elasticity of demand. Law of demand tells us that the quantity demanded of a good and its price per unit is negatively related to each other. It implies that quantity demand changes in response to change in the price of a good. But the important question is, to what extent the quantity changes? If for a unit change in price, the magnitude of change in quantity demanded is very high, then the demand is said to be highly responsive to changes in price and vice versa.
1.5.2 Measurement of price elasticity of demand. Point price elasticity of demand is denoted as E subscript P and is defined as the ratio of proportional change in the quantity demanded to proportional change in price. E subscript P is equal to delta Q by Q subscript I within brackets divided by delta P by P subscript I within brackets is equal to Q subscript F minus Q subscript I by Q subscript I within brackets, this divided by P subscript F minus P subscript I by P subscript I within brackets. Here, we assume that when the initial price was P subscript I, then the quantity demanded of good was Q subscript I, and when the final price became P subscript F, then the quantity demanded became Q subscript F. In the above ratio, delta Q by Q subscript I is equal to Q subscript F minus Q subscript I divided by Q subscript I is the proportional, that is, relative change in quantity, and delta P by P subscript I is equal to P subscript F minus P subscript I by P subscript I is the proportional, that is, relative change in the price. Change in units in which you measure quantity or price does not matter, as it does not change elasticity of demand, thus allowing us to compare responsiveness of demand of different types of commodities. Taking an example, suppose the per day demand for cricket balls in a small town is 200 balls, when the price per ball is rupees 10. Suppose now the price goes up to rupees 30 per ball. Since balls have become expensive, the quantity demanded in the town goes down to just 100 balls. It means that the change in quantity demanded is minus 100, which is equal to 100 minus 200 within bracket balls, while the change in price is rupees 20, which is equal to 30 minus 10 within brackets. The proportional change in quantity demanded is therefore equal to minus 100 balls divided by initial quantity of 200 balls, that is minus 1 by 2, whereas the proportional change in price is rupees 20 divided by initial price of rupees 10, that is 2. Thus, when the initial point on the demand curve is 10, 200 and the final point is 30, 100, the point price elasticity of demand is minus 4. This looks like a highly responsive demand. Page 28. We know from the law of demand that if the change in price, that is, delta P, is positive, then the change in quantity demanded, that is, delta Q, must be negative. Therefore, the elasticity calculated as the ratio E subscript P is equal to delta Q by Q subscript I divided by delta P by P subscript I must have a negative sign. But since generally all demand curves have a negative elasticity of demand with respect to price, therefore we ignore the signs of elasticity when comparing elasticity for one demand with that of the other. For example, consider two demand curves having price elasticity of demand as -2 and -1 respectively. Although numerically -2 is less than -1, the demand curve with elasticity value of -2 would be considered more elastic than the demand curve elasticity value of -1, since we are only comparing magnitudes and not signs. We may rewrite the elasticity formula in terms of absolute values, that is, only the magnitudes, by writing them inside the modulus bar, which is two parallel vertical lines, as follows. Mod of E subscript P is equal to mod of delta Q by Q subscript I divided by mod of delta P by P subscript I, which is equal to P subscript I by Q subscript I divided by mod of delta P by delta Q.
Table 1.1. Price elasticity of demand at various points on the demand curve. In this table, we have three columns: price elasticity of demand, nature of demand, and types of commodities. First column, price elasticity of demand. Mod of E with subscript P is equal to infinity, that is not defined. Nature of demand, perfectly elastic. Mod of E subscript P is greater than 1. Nature of demand, highly elastic. Types of commodities, luxury goods, airplane tickets, Audi cars, etc. Price elasticity of demand. Mod of E subscript P is equal to 1. Nature of demand, unitary elastic. Price elasticity of demand, types of commodities, dash. Price elasticity of demand. Mod of E subscript P is less than 1. Nature of demand, highly inelastic. Types of commodities, necessity goods, food, electricity, clothing, etc. Price elasticity of demand. Mod of E subscript P is equal to 0. Nature of demand, perfectly inelastic. Types of commodities, dash. Figure 1.15a. Perfectly elastic demand curve. Here we have two axes, x-axis and y-axis. The quantity is represented on the x-axis and price is represented on the y-axis. We find that the demand curve is a straight line, which is the slope is equal to 0. E with subscript P is equal to infinity. As in figure 1.15a, the demand curve is horizontal. That is, it has a 0 slope at all points. So the elasticity of demand at all points on the curve is infinite. Therefore, a perfectly elastic demand curve is horizontal. As depicted in figure 1.15b, a flatter demand curve represents a highly elastic demand, and the figure 1.15c marks a steeper demand curve that represents a highly inelastic demand curve. Also note that for the same change in price from P1 to P2, a flatter curve, figure 1.15b, has a greater response to change in quantity demanded to that of a steeper curve, figure 1.15c.
Page 29.
Figure 1.15b. Highly elastic demand. Here we have a graph with two axes. The x-axis represents quantity. The y-axis represents price. We also have a downward sloping line. This line represents that at price P2, Q2 quantity is being demanded, and this can be understood from the point F on the line. Also, at price P1, Q1 quantity is demanded, which can be understood from the point I on the line. Figure 1.15c. Highly inelastic. Here we have a graph with two axes. The x-axis represents quantity. The y-axis represents price. Here we have a downward sloping line which is much steeper as compared to the one we had before. At price P1, Q1 quantity is demanded, which is represented by the point I on the line. At price P2, Q2 quantity is demanded, which is represented by the point F on the line. Figure 1.15d. Unitary elastic demand curve. Here we have a graph with two axes. The x-axis represents quantity. The y-axis represents price. We also have a line in the shape of a rectangular hyperbola. This line represents the equation P is equal to K by Q. It is only in case of a demand curve shaped as a hyperbola that the elasticity is constant at all the price levels. In particular, the magnitude of elasticity is constant at 1 unit. As drawn in the figure 1.15d, this demand curve is shaped as a rectangular hyperbola, and it has the equation P is equal to K by Q, where K is any positive real number and P and Q are price and quantity respectively. Figure 1.15e. Perfectly inelastic demand curve.
Page 30.
Here we have a graph with two axes. The x-axis represents quantity. The y-axis represents price. We have a line which is parallel to the y-axis and represents slope is equal to infinity. It also makes us understand small e subscript p is equal to 0. As in figure 1.15e, the demand curve is vertical, that is, has an infinite slope at all points. So, the elasticity of demand at all points on the curve is 0. Therefore, a perfectly inelastic demand curve is vertical. A point like M on the straight line AB, as given in the figure 1.16, would divide it into two line segments. AM is called the upper segment and BM is called the lower segment. The elasticity at any point M on a straight line demand curve AB would be given by the ratio of length of lower segment MB to the length of upper segment AM. Table 1.2 summarizes the elasticity of demand at different points along the linear demand curve. Thus, price elasticity of demand, or small e subscript p, at a point can also be calculated as small e subscript p is equal to lower segment by upper segment. Figure 1.16. Elasticity along a linear demand curve. Here we have a graph with two axes. The x-axis represents quantity. The y-axis represents price. On this graph, we have a line AB. The point A lies on the y-axis and represents mod of small e subscript p is equal to infinity. The point M lies in the middle of the line and represents mod of small e subscript p
is equal to 1. The point B lies on the x-axis and represents mod of small e subscript p is equal to 0. From this line, we also understand that AM shows us an elastic range and MB shows us an inelastic range. Table 1.2 Elasticity at different points along a linear demand curve.
Page 31.
Here we have a table with 5 rows and 4 columns. The first column represents point on the line. The second column represents relation between upper and lower segments. The third column represents elasticity at that point, and the fourth column represents remarks. The values in row 1 are: point on the line is B, the lower segment is equal to 0, and upper segment is equal to AB. Elasticity at that point is equal to 0. The remarks are that this is perfectly inelastic point on the linear demand curve. The values in row 2 are: the point on the line is between M and B. The lower segment is less than the upper segment. Elasticity at that point is less than 1. And the remark here is that this is inelastic range of a linear demand curve. The values in row 3 are: point on the line M. Lower segment is equal to upper segment. The elasticity at that point is equal to 1. The remark is that elasticity is always 1 at midpoint of a linear demand curve. The values in row 4 are: the point on the line is between M and A. The lower segment is more than upper segment. Elasticity at that point is greater than 1. The remark here is that this is elastic range of a linear demand curve. The values in row 5 are: point on the line is A. Lower segment is equal to AB. Upper segment is equal to 0. Elasticity at that point is equal to infinity. The remark here is that this is perfectly elastic point on the linear demand curve. Page 31.
1.5.3 Relation between price elasticity of demand and total expenditure. Provided there are no taxes on sale of commodities, the expenditures of consumers, that is, price per unit into quantity bought, must be equal to the revenue of the sellers. Therefore, we will use total revenue, that is TR, and total expenditure, that is TE, interchangeably. When elasticity of demand is greater than 1, that is, demand is elastic, then a rise in price leads to a proportionately larger fall in the quantity demanded. As a result, the total revenue decreases. A fall in price will increase quantity demanded proportionately more, thereby increasing the total revenue. In case the elasticity of demand is less than 1, that is, demand is inelastic, then a rise in price will lead to a proportionately smaller fall in the quantity demanded, and so the total revenue will increase. A fall in price will increase quantity demanded, but in a smaller proportion. Thus, the total revenue will decrease. For elastic demand, price and TR are inversely related. That is, increase in price will have decreased total revenue, whereas for inelastic demand, price and TR are directly related. That is, increase in price will have increased total revenue. The relation between change in total revenue and the price elasticity of demand is explained in Table 1.3. Table 1.3 Relationship between total revenue and elasticity.
Page 32.
This table has 4 columns and 2 rows. The columns indicate change in price, change in quantity in relation to price, elasticity of demand, change in TR. The row-wise values are: row 1, price rise. Change in quantity to relation to price is as follows. When quantity falls proportionately more, elasticity of demand is greater than 1, and change in TR is that it falls. When quantity falls in the same proportion to price rise, that is, elasticity of demand equals 1, then the TR is unchanged. When quantity falls less in proportion to price rise, that is, elasticity of demand is less than 1, then the TR rises. Row 2, price fall. When change in quantity in relation to price is that the rise in quantity is proportionately more, then elasticity of demand is greater than 1. The TR rises. When rise in quantity is in same proportion to price fall, elasticity of demand equals 1. The TR is unchanged here. When rise in quantity is less in proportion to price fall, then elasticity of demand is less than 1 and the TR falls.
Test your understanding.
1.
For each of the following goods, identify whether they have elastic or inelastic demand. Also, give reasons for your answer.
A.
Washing machine,
B.
salt,
C.
jewelry,
D.
branded clothes,
E.
medicines.
2.
What will happen to the expenditure made on Coke by a consumer if there is a rise in the price of Coke?
I have a question here.
What will happen to the expenditure made on a soft drink by a consumer if there is a rise in price of the soft drink?